So first I'm going to do a little introduction here. It's not a little one, it's medium sized. But anyway, I'm pleased to be able to introduce this special guest, Sam Glassenberg. He represents what our new Game Studies and Design program is intended to do, which is to bring to light the power of games to improve our lives well beyond their entertainment value, which of course is pretty significant in its own. Sam is a UIUC computer engineering alum who went to earn an MS in CS graphics at Stanford and then lead a number of video game companies and groups. By the way, we do have, hopefully, I'm happy to say that Sam in the future may not have to leave UIUC to get a master's degree because we're just about ready with our master's degree in game studies and design here. Hopefully it will be coming soon. We'll have more about that. Hopefully it will be coming soon. We'll have more about that in the near future. Sam is the visionary behind and CEO behind Level X, and the company that creates mobile, AR, and VR medical video games for physicians. And I think this is really a profound thing that he's doing. Sam has put together an award-winning interdisciplinary team of game developers and physician experts to revolutionize the way physicians sharpen their skills, really, and stay sharp. So Level X's games are played by over 750,000 medical professionals, and Level X has been named as one of the Fast Company's world's most innovative companies list two years in a row, health category 2021 and games category 2020. Before Level X, Sam established his roots at LucasArts. He worked on the PlayStation 2 and Xbox games for Star Wars films. He led the DirectX team at Microsoft, where he accepted on behalf of his team a technical Emmy that recognizes their contribution to the state-of-the-art in interactive entertainment. And he's also the CEO of a top indie game publisher. He's done a little bit of everything in Hollywood, and he's created award-winning mobile games for tens of millions of players based on popular IPs like The Hunger Games and Mission Impossible. And in 2021, Sam was Pharma Voice's top 100 of the most. Here we go. She put this in there too. You want to hear this? Yeah. No. You want to hear that last part? Okay. Welcome, Sam. Okay. I mean, it's got a little deep back there. We're
good. We're good.
All right. So I'm gonna turn.
Was there anything like important at the end about that? You know, there's going to be a test at the end of this or something?
No, I think you're like SIGGRAPH's real-time live audience.
Yeah. Okay. Yeah, that's fine. Okay. Yeah. Hi everybody. I'm Sam. Hello. All right. Sorry. Like once you start listing like the awards I win from like pharma, let's just be clear. There's the video games industry, they set the bar very high. There's healthcare, they set the bar very low. For video games folks to win awards in healthcare is very easy. And I'm realizing this is being recorded. So, all right, maybe I'll be more diplomatic, probably not. Okay, so Dan asked me to talk about my background, but mostly about applying video game technology and neuroscience-based design in healthcare. So I kind of just, based on that, I put together some slides a few minutes ago. So it'll be a little bit of PowerPoint karaoke. Next slide will come up, and I'll talk to it, and I might be surprised. Okay. I'll cover all that. There are a couple things were stale in the intro, but I'll cover that as we go through things. Okay. So I'm very lucky. I've spent my career at the intersection of video games and other industries, video games in film, video games in hardware, video games in medicine. We're actually doing some work in space health. Happy to talk about that at the end if we want to. Doing some fun work with NASA. I'm going to start with an example in medicine because it's just sort of going to be pretty obvious, and then we'll go from there to talk about, I'll go a little bit about my career and then talk about other applications. So the first example I'm going to give you. So Level X, I run a company called Level X. We have 1 million medical professionals playing our games. I'll tell more about Level X in a minute. And so I'll give you an example of like a problem that can be solved with video game technology. So recently we launched a game in dermatology. And in talking to dermatologists, one of the things we do is we capture the challenges of the practice of medicine using video game mechanics. And so we said, all right, what are some of the challenges in dermatology you wish you had game content for? And well, I think this problem kind of speaks for itself. So there's like a known issue in dermatology. So the first thing they said is skin of color. What does that mean? So there's this known issue in dermatology where people of color, when they go to the dermatologist, they do not get the outcomes that are as good. And it's not because their doctor is malicious. It's simply because they have not been trained on how to recognize skin diseases on a broad range of skin tones. So we set out to go make a video game on the subject, and we said, great, we're going to go grab a bunch of reference material from the from the dermatology reference of different skin diseases on different skin tones, and then we're going to make a game out of it, present to doctors. And what we discovered is the reference material doesn't even actually exist. This is what doctors learn from. This is Fitzgerald. This is like the key. This is like one of the leading derm reference books, and I think you can see the problem. Everything is on, like everything, all the reference material that doctors learn from is on the same skin tones. And so, this is something that in video games we're actually pretty good at, which is recreating skin. This is an example from Call of Duty, where basically, this is the level we create characters in modern video games. So one of the things I used to work on at Microsoft was how do we make, video game skin look real? So an example of one of the things we do at Level X, just to sort of introduce the problem space, is, for example, how to use video game skin rendering technology to create systems that allow us to generate, let's say, any skin disease on any body part, on skin at any severity, on skin of any color, under any lighting environment. So like none of these images are real. These are all screenshots from our various dermatology video games where we're able to basically generate any combination of skin disease in order to help train doctors' brains how to recognize skin disease on skin tones they don't see every day. And so if any of you, like, for example, are familiar with, and it doesn't just extend to technology, it's also art and design. We'll talk about the design a little bit. Here, this is an example of, Substance Designer. You can't see the whole node network. There's a few hundred nodes here, where we're basically procedurally generating, in this example, plaque psoriasis. We're basically creating systems where, based on physics, based on biology, where, all using video game tech, where basically a dermatologist can stand over an artist's shoulder and say, make that redder, make that thicker, make that wetter in the crevice, and then ultra-realistic imagery is just dynamically generated from the system. So these are just like immediate, obvious examples of how you can use video game technology, more or less out of the box, building on top of it with some science and bio, to really address, call it racial disparities in healthcare, like major societal problems. And we have examples of this, not just, this is the most obvious visual one. We do this for COVID, we do this for, ultrasound training. I literally just got back a few weeks ago from Ukraine. We're using these to help, do basically frontline medical training to, save lives and limb where unfortunately it's needed. So I've spent my career in games. I've managed game teams all over the world. One of the cool things about games is unlike Hollywood where things are very centralized, games are really developed worldwide. So I've managed game teams obviously throughout the US, Scotland, China, Russia, Israel, really all over the world. I'll start a little bit of my background. I'm happy to talk more about my background if you want. We're a small group, so tell me what's interesting. I started out at University of Illinois, undergrad computer engineering. Stanford, they didn't have game degrees back then, so my graduate degree was computer science with a focus on graphics. Just did a lot of work in simulation and graphics. The classes at Illinois were, in Stanford were comparable. The grades were higher at Stanford because they grade inflate, but I had a great time here, and there's a lot of great things to learn. Started out, we already talked about LucasArts, Microsoft. Actually, when I was here at Illinois, and even in high school, I did animation as a hobby. And so when I was hired at LucasArts, I was actually hired as an animator. So my job was literally to fly spaceships. It was between episode 1 and episode 2. I was an in-engine cutscene animator for Jedi Starfighter and a bunch of other Star Wars games. But I was the only engineer on the art team. And I was very lucky because I was working on a team with probably the most talented artists in the industry. And I very quickly realized that no matter how much I invested in my art, I was never going to be as talented as they were. But I had this convenient degree in engineering from University of Illinois. So all of the difficult problems that the art team was facing. Like, hey, they wanted to be able to create, they wanted to have a level where you could fly around an asteroid, but the terrain software didn't work on spheres. Or this was back before they had light baking, and they wanted to do light baking. So like I sat down and figured out the math and started making tools, and that really set the stage for my career, which I realized like my role in life is not to be a great artist. I'm just not that good. My role in life is to make sure that technology does not get in the way of the creative vision of artists who are more talented than I am. And that really sort of set the stage. So I used to run the DirectX graphics team at Microsoft. Folks know what DirectX is? Okay, great. That was enthusiastic. My job at DirectX was to build the matrix, basically figure out how to leverage Moore's law to make video games look real. You guys know this stuff, so I can probably skip through it. But this idea that like in video games, we've been able to take advantage of the doubling of compute power every 18 months to get to like this was the best looking video game character we had in video games when I joined Microsoft in 2001. And when I left in 2008, we were sort of getting to these levels. So to the point like where, today you saw the images earlier. So my team's job was basically to figure out how do we make video games look real. If you know, DirectX is basically the layer between the hardware and the software, between the game engine and the hardware. So we were doing everything from standardizing what the hardware needed to do, coming up with all sorts of algorithms and standards and things like that. So that way you could build a game kind of once for Xbox, for PC, arguably for PlayStation, and not have to do custom things for AMD hardware, Intel hardware, NVIDIA hardware, and so on. In order to figure out like what the industry wanted to do, because we were basically like our job was to predict the next 5 to 10 years, because game hardware, GPUs, take 5 years from like the initial design to the point where it shows up on the shelf, I guess online. And so what I would do is bring together like the top game developers from across the industry. We had Sweeney and Carmack and like all these folks. We would get together at least once a year, like sort of some secluded resort in Western Washington, and figure out, all right, what do they want to be able to achieve visually in video games 5, 10 years from now? So like, probably the top 50 game developers, you want to achieve better environments, more realistic shadows. Shadows used to really suck in video games. Denser vegetation. We talked about better skin, more realistic characters. So for example, this is an example of like looking across industries for reference. So one of the things that would often come up in these discussions was we wanted to create more realistic characters in video games. This is call it maybe it's 2004, 2005. So back then we would say, all right, well, what is the most realistic character we have in a video game? In a most realistic computer-generated character in general. At the time, it was Golem in Lord of the Rings. So I brought Bay Rate, who was the tech artist on Lord of the Rings, to basically sit down with our group and tell us, like, how did you make this? We explained, how they did it with, back they had 6 hours to generate a frame. We have to generate 60 frames a second. But he would say, all right, this is the math we used, and blend shapes, and how we created it with, display subdivision surfaces and all that. And we'd look at it and we'd say, all right, if you follow Moore's law, when are we going to be at the point where we're going to be able to do that in real time? And what are we going to need in the ecosystem in terms of hardware, software, SDKs, tools? We'd have the Autodesk folks in the room, the Softimage folks in the room. They weren't all at the same company back then. To figure out, all right, what do we need to do to make these things happen? And so that was my time in DirectX. Happy to answer any questions about that later on. After that, I ran a company. I'm not going to have a whole background on it, but basically we became. They were started in Israel. We sort of turned them into the go-to video game studio for Hollywood, making games for The Hunger Games, Mission Impossible, Rocky, Power Rangers, Narcos, of course, Hot Tub Time Machine 2. I got to put some of my favorite comedians in their first video game. That was also great. And we launched, it was the first time like a major piece of call it major franchise lore was released in a video game. We had done, LucasArts are always very careful to like not reveal too much of the universe in the games. But here, like the actual official map of Panem was released in the video game. I drew that map, working with Suzanne Collins. It was a lot of fun. Again, like happy to answer questions about any of these things if we want. Okay, so how did I go from Hollywood video games to making video games for doctors. I would love to say that this was some grand idea I had, but it all happened by accident. I've had this fun career in video games, which has basically made me the disgrace of my family because I come from a long line of doctors. Literally up until 2 weeks ago, the Journal of the American Medical Association had either my mother or my grandfather on the masthead. My father's an anesthesiologist, my wife's a doctor. I'm the idiot who didn't go to medical school. To show you how bad it got, so in 2006 when I was at Microsoft, I accepted a technical Emmy on behalf of the team for pushing the cutting edge of video game graphics. That's me, I was younger. That's Jensen Wang, he was also younger. And so great, so I call home to be like, hey, I'm accepting an Emmy. It's red carpet. It's not the Emmys they show on TV, but it's the same statue. They do it beforehand. So I call home. My dad answers the phone. He's an anesthesiologist at Northwestern in Chicago. And without skipping a beat, he goes, Sam, that's very nice, but in this family, we only recognize Nobel Prizes. You can still go to medical school. Love, Dad. This is the world that I come from. So in 2012, he gave up, and he said, all right, Sam, you're too old to go to medical school. Put all this gaming nonsense to good use. Make me a game to train my colleagues to do a fiber optic intubation. It's a tricky procedure. We only do it on difficult, rare presenting patients. Even experienced anesthesiologists will struggle with this if they haven't done enough cases. Oh, but I don't want to drag any of my residents to the simulation center. Can you please just make me a game they can play on their phones? I'm busy running this Hollywood game company. Sure, Dad. So I sit down for 3 weekends, I think with some early version of Unity, and I throw together this crappy little game that I upload to the App Store. And I don't think about it again. And 2 years later, he calls me. He goes, hey, Sam, how many people downloaded it? I go, Dad, I don't know how many of your friends downloaded your laryngoscopy game, but I'll go on iTunes and I'll check. And we had 100,000 doctors, nurses, and airway specialists who've been playing. I had by accident created, I think was one of the most popular medical training tools ever. So I Googled it to try to figure out how this happened, because I had put ilarynx at Glassenberg.com as the iTunes email address. I didn't check it. And I discovered, unbeknownst to me, they've been doing efficacy studies at medical schools all over the world that showed this game I made for my father was drastically improving physician performance. So that was, I would love to say Level X was some grand idea that I had, but it's not. It was accidental and, some parental guilt. So the question then became, all right, so after Funtactics was successfully acquired back in 2015, I started Level X. So basically, what if it wasn't just me? What if instead we basically took the top video game designers, artists, engineers from across the industry? We've worked on everything from Mortal Kombat to Words with Friends, and team them up with literally hundreds of physician advisors across every major therapeutic area in medicine to capture the challenges of the practice of medicine using video game mechanics. Now we have over 1 million medical professionals playing, 3 million players, where basically doctors are earning continuing medical education credit, literally you're earning CME credit toward renewing your medical license from playing video games. We work with 30 out of the top 40 life science and med device companies, Medtronic, Boston Scientific, Novartis, and to basically accelerate the adoption curve in healthcare using video game technology and design. 3 years ago, we were the first video game company to ever be acquired by, called a large healthcare company. We were acquired by a company called BrainLab a few years ago. They're based in Munich, and they make basically all the neurosurgery hardware and software. So we say Level X is like the Matrix. You can't be told what Level X is. You have to see it for yourself. So I'm just going to start doing some demos on my phone. So ignore any angry text messages that I might get while we do this. Oh, is this one of these Sony TVs that takes a minute to switch devices? Oh no, great, perfect, okay. All right, so all these games that I'm showing you here, at least at the beginning, you can just download from the App Store if you want. I'm going to start with GastroX because I always like to start a demo with a colonoscopy. Wow, tough audience. All right. Maybe squeamish? Is anyone squeamish? Yeah, all right. Okay, so I think we have a few 100,000 medical professionals playing this game. It's filled with dozens of real cases that have been submitted by doctors all over the world. Here, I'll do this one. I like to show this because this demonstrates using technology this illustrates game technology, and then we'll talk a little bit more about game design. So this isn't just a 3D model, and we launched this years ago. This works on like an iPhone 6. So it's not just a 3D model, it's a totally interactive virtual patient. Everything's squishy. I can grab anything anywhere. It behaves just like it would in real life. In fact, as you pull it toward the light, it glows with subsurface scattering, like when you hold your hand up to a flashlight. This is going to get a lot worse. So this is a routine polypectomy. It's kind of like a hidden object game. You need to find all the polyps that hide behind folds. We use different techniques to reveal them. Here I've got one that's out in the open, so I'll come in and grab it. What I don't realize, though, is this polyp is embedded on a blood vessel. So when I remove it, I trigger a bleed a meter inside the body. And here we have 3D computational fluid dynamics running on a cell phone, the thing that drops my calls all the time. I mean, this thing has more compute power than an Xbox 360, and it's in my pocket. So I can spray water, try to get to the source of the bleed. All that does, though, is dilute the blood. So we need to take more drastic action. We'll do audience choice. Argon plasma or epinephrine? Epinephrine. Okay, epinephrine. So I'll take my endoscopic needle. We'll inject some epinephrine. All right, good job. Objective achieved, bleeding stopped. You can give him a round of applause. This is good. Now I have this nasty mess of blood and water, so I can go and suction it up, find more polyps, but it's a totally interactive patient. You can take my argon plasma coagulator, cauterize anywhere. You see how the tissue kind of behaves differently. Well, until you cause so much damage, you fail the case. So this is an example of game technology and design being applied in healthcare. Let's do a physics puzzle. Here, so this, for example, this case this is from Dr. Kyle Hogarth, the head of the Advanced Bronchoscopy Society from University of Chicago. A carpenter was holding a bunch of nails in his mouth while he was hammering, and he inhaled one and punctured his bronchus. So here, let me turn the audio on. Audio on. That. No. There we go. It's nice. Okay, all right, so there's the nail. We can see where it embedded. All right, so, what's going on here? Hold on. Oh, 1 second. Let me restart the level. So now, okay, so there's the nail. I can see where it embedded. And so, what is going on with my phone right now? All right, well, we'll see if I can get it. Okay, so what he did was, Dr. Hogarth goes, all right, I've got my endoscopic forceps. Let me come in and try to grab the nail. And so he goes in, he grabs it, and no matter what angle he came in at, you'll notice the mucus now attaches it to the wall because it's all physics-based. So no matter what angle he came in at, he simply could not get that nail to budge. But he goes, all right, my endoscope will bend at the tip, but only in one direction. So what I need to do is I need to reorient myself so the bend of the endoscope is in the direction of the nail. Twist my tools around, come in at the base, and now when I pull the trigger, I can yank it out. And so, oh wow, it's still pulling on the mucus. Okay, so I'm not going to embarrass there's a whole bleed and I got to deal with it. But so the idea here is we talk about emergent gameplay, right? Gameplay that emerges from physics. We're able to capture the challenges and help you develop that mental model of that complex endoscopic maneuver using video game physics. While I'm here, why don't we do this example? I'll do this. So sometimes the things that we do are very visual, and sometimes they're not. So this sort of example is, this is sort of really using more of the neuroscience of games. I've got visuals here, but they're really just there to add what we call juice. This is a diagnosis game. And so here, this is not surgical, right? This is cognitive, this is clinical. Your patient presents with a chief complaint, difficulty breathing, or no, in this case, male with cough. Here are the vitals coming into the clinic. And this is a game that trains your brain how to do reductive reasoning, how to do, let's say, rare disease diagnosis or difficult disease diagnosis. Now, there have been attempts in the past to gamify diagnosis. They're all terrible. It's all like, here's what the test results are. What do you think the patient has? Like, it's a quiz. It's not interesting. So here, what we do is you've got 17 diseases that it can be. We're not going to reward you for guessing the right answer. It's a bit of a strategy game, resource management. You have to ask the right questions, order the right tests. They get more and more expensive and take longer as you go in order to not only figure out what the patient has, but eliminate the other 16 differential diagnoses. So this is an example. You notice we build up a little bit of suspense here. Like, it doesn't actually take time to run the tests. But it's all about, managing dopamine release, balancing reward and frustration, challenge and skill to, optimize the release of neurochemicals and get people learning. And so I'm not going to play through these levels. All take about 5 minutes, but I'm just sort of giving you a sense of it's not the obvious like first-person shooter type stuff. A lot of this is purely cognitive puzzles, strategy games. Let's see where. Let's do cardiology. I like this game. This is another example. So a lot of the stuff I was showing you is under visible light. Here, this game is played under fluoroscopy. So here, you can download these games and play them, show them to your friends, especially the ones in medical school. So here, this game is played under X-ray. So from a graphic standpoint, we're tricking the GPU to basically simulate the absorption and scattering of X-rays through different tissues. Here, it's a puzzle racing game. So, all right, so this is the heart under X-ray. You can't really see it. In order to see where you're going, you need to inject the radio-opaque contrast agent to see where you're going. It's probably too old. Has anyone here played Doom 3? Okay, you know that like infernal mechanic where you can either have the flashlight or the gun, but not both at the same time? That's interventional cardiology. So I can either sort of see where I'm going, or I can use my tools. So here I have to navigate the guide wire through a live beating human heart, choose the right tools in the right configuration, place them at the right position in the heart. And then let's say I take a covered stent, like the wrong tool, place it at a bifurcation at a junction. When I inflate my stent with a little balloon inside, now I've blocked blood flow to a side branch, so I have no blood flow on that portion of the heart. So like these are examples of how you develop these mental models for these complex systems. And then, for example, we work with industry. So here there's content from Novartis, Philips, J&J. So here, for example, I can play through some of the same levels, only here I've unlocked Philips's intravascular ultrasound probe. So I can basically, now I've unlocked this tool and I can learn about the benefits of the probe and how to properly, let's say, size a stent under ultrasound. So here I can see what the stent looks like under X-ray fluoroscopy, and then I can place my IVUS probe, scan backwards, and now I can, what we're actually doing here, this comes out of a grant we have from NASA, we're actually doing simulated ultrasound. I'll show that to you in a second. So here I'll quickly size a stent badly, place it, inflate it. There's a whole thing where there's an embolism. I'll skip it. So now what I can do is I can take my IVUS catheter. Oh, here we go. Good. Okay. And then now I can scan it again. And you can see here we're actually doing effectively ray marching. Now you can see the metal stent that is now, I can see how well it adhered to the blood vessel. But you'll notice the stent casts a shadow. Sound actually casts a shadow. You can see echoes. Ultrasound is very much like visible light, but also very different. Helping people develop a mental model of like what that, like an experienced stenographer can look at an ultrasound image and just be like, oh yeah, that's blood, that's water, that's fluid, that's a kidney. Whereas you and I might look at it and just be like, what is that noise? I can't tell what that is. And so how do you help a novice develop that same mental model that the expert has? You can use video game mechanics for that. And we have a large grant from NASA that we've been actually using to do this inside the heart, but also throughout the entire body. Well, I'll do more phone demos later. How are we doing for time? That was a question for you, Dan. So how much time do I have then? 10 minutes. All right, great. Really? It's not going to recognize the thing again? All right, hold on. All right, while I'm playing AV jockey here, does anyone have any questions?
I have a question, Sam.
What do we use for reward systems? So, so we have a bunch of outer loop mechanics that we use. The reward systems that we generally use are usually completion mechanics. So we do some competitive stuff, but because doctors can be very competitive, but mostly it's completion. So it's like, hey, you know what, if I switch, it's going to take a minute. Or I'll switch at the end, I'll show, but like, for example, we do things like skill webs, where we'll show, how are your skills developing in different areas, what percentage of content have you completed. Oh, if you just do a little bit more, you'll earn a full CME unit. Might as well, right? So we'll take advantage of, honestly, we'll take advantage of sunk cost fallacy and other, some of the same techniques that we use in consumer video games, and we'll just unleash it on unsuspecting doctors. Yes?
Creating your first game, how much knowledge do you have about, like, just the procedure?
When I created that game for my dad? He sent me some videos, and I think, for years, he'd been trying to get me to go to medical school, so he kept dragging me to Northwestern for various things. So I think at some point, he made me intubate a mannequin, like a plastic model with the thing. So I had like a decent understanding of the procedure and the challenge. And then mostly just, it was, I guess I had a good understanding of like the physics and like what made it hard. So that's how I did it. But a lot of like with game developers, I've got some funny stories if you want, which we can actually get to in a minute, around sort of how video game developers learn about medicine, and what happens when we discover how far behind medicine is. Actually, why don't we can jump to that. Here, I'll pull that up real quick. This story is called The Pig in the Box. Pig in the Box. Okay, so on the general topic of like, how do you ramp game developers? I'm a game developer, I don't know anything about medicine, how do I ramp you up on medicine? So the truth is, and actually I'll just sort of make a statement, which is, doctors are not like some special species of human. Like, they're like us. They've just studied a lot of medicine. And what that means is, like, you're never going to be as good at medicine as a doctor is because you just don't have the background and training and everything else. However, there's no, like, any specific concept that you want to understand, you can understand, right? You just have to have the intellectual curiosity and learn it. And so you're not going to have the breadth that doctors do, but you can gain depth in a particular discipline and to the extent of actually like, using tools like, intubating a mannequin, for example, or observing doctors in clinic, or even in surgery. We'll scrub game developers up and send them into operating rooms. It's great. Okay, so this story is called The Pig in the Box. And so this is a story about how when we were making GastroX, that game I showed you with the argon plasma coagulator. So early on, one of the ways that we ramp, like if you want to ramp somebody up in the games industry real quick, what do? Send them to GDC. You go to the conference, because that's like the best way in a few days to really get a sense of like what's exciting, what's going on, what are people doing. And so we do the same thing. Now we're headquartered in Chicago, so all the major medical conferences are at McCormick Place. So it's super convenient for us. Oh, we're going to do a game on pulmonology. Great, McCormick Place, 2 weeks from now. So we sent a team to the gastroenterology conference, Digestive Disease Week. And before we went, we talked to some gastroenterologists, and they said, look, no matter what you do, if you're making a game about gastroenterology, you have to feature the argon plasma coagulator. That was that lightning gun I used at the end. It's a plasma rifle. Like, that's what it is from your favorite video game. It's just very small. And we use it to cauterize wounds, but it's awesome. And so you have to feature it. And so we have a team of game developers, and one of them, Andy, he was our graphics engineer. He actually worked at Volition for a little while. And so he ran around the show floor until he found a booth for a company that makes the argon plasma coagulator. And the APC was very cool. What was more impressive was the simulator that they were using to train people on it. Now, medical simulation, I can show you pictures, is decades behind the state of the art in video games. Like, this is one of the gaps we're working to close at Level X. But this example, this simulator, was the best one that we had ever seen. So it looked like a PlayStation, but the controller was the colonoscope. Like, it was a colonoscope. And as the sales rep moved it, and he cauterized stuff, it looked super real. Like, the tissue moved very realistically. It didn't have blood. Blood is really hard to simulate. But like, when he cauterized tissue, like, you saw smoke. It had vorticity. Like, it was really good from a games perspective. So Andy starts bombarding this guy with questions. Like, whoa, what engine is this? Is this Unity? Is this Unreal? Like, whoa. And it's a sales rep. He has no idea who made the simulator. So the two, like, he brings over his engineer, Andy, he's bombarding him like, what's the hardware? NVIDIA, OpenGL, DirectX, talk to me. Like, how'd you make this? And like, the guy's looking at him funny. They talk over each other for about 3 minutes until finally the company representative goes, wait a minute. You do realize it's a pig in the box, right? And he goes, what are you talking about? He goes, the day before the show, we take a slaughtered pig, we cut out its intestines, and we sew it into the inside of the box. We have to do a new one every 2 days because after that it starts to smell. Now, you're a video game developer, right? It's 2018. There's a pig in the box. Like, we solved this problem decades ago. What are you doing? And so we have tons of stories at Level X that follow sort of the same arc, which is you have this, like, as we discover how doctors learn things, and it starts, you learn, like, there's this we call the ha-ha moment, where you go like, ha-ha, I can't believe there's a pig in a box. That's ridiculous. And it's followed immediately by this overwhelming feeling of dread when you realize, wait a minute, this is an argon plasma coagulator. I use this when I'm doing endoscopic surgery, a meter inside the body, and I accidentally nick a blood vessel, it starts spewing blood, and I need to cauterize it to seal the wound. But the dead pig intestines don't bleed, which means that the first time a surgeon ever actually uses this on a bleed, it's going to be inside a live human being. And that is the moment when the video game developer goes, oh, this is a very important problem to solve. And so we have lots of stories like this. But that was an interesting segue, so thank you for the question. How are we doing should I go back to the main deck? Should we want to call it and switch to Q&A? I can talk more about the neuroscience of games. Maybe take questions? Great. We'll switch to questions. I like to answer questions with demos. So feel free to ask. They are. We have 2 million people playing our games who aren't doctors. I don't know why. Some of the games, like, you can play GastroX and PulmX if you're not a pulmonologist or a gastroenterologist. CardioX is really hard if you don't, like, because these games are not for medical students. They're for practicing doctors. It's CME. So we don't teach you how to become a doctor. We assume you are one, and then we just present you with rare, difficult cases. So if you don't know your way around the vasculature of the heart, like, we're not going to teach it to you. I think top derm is probably the most difficult because that one, like, if you don't know dermatology, it's just really hard. We're now starting to get into, like, with some of our medical device and life science customers, we've known for years that doctors have been using our games to explain concepts to patients. And so now we're finally starting to actually make games for patients to help them understand things. But we usually keep that, it's usually pretty limited to, like, when a patient really needs to understand something medically, as opposed to just like, here's a game to convince you to take your pills every day. Like, we don't do that stuff. That's other people. Did that answer the question? Great.
What is the biggest difference you feel like?
I would say that the differences are fewer than you would expect. I think, obviously the difference here is, you're dealing with the realm of medicine, and therefore, you don't have nearly as much creative leeway, right? Because ultimately you need a degree of medical accuracy. You can abstract things, right? Like, you don't have to recreate everything, but you do need to, you do need to have, like, there are certain things where you can lead people astray. I think one thing that people often assume is they go, oh, how can you make a game when you're dealing with these levels of creative constraints? And the people who usually ask that question have never worked in making games for, let's say, Hollywood movies. So when people say, like, I say actually people assume there are more differences than there are. Like, when we make games that are CME accredited, for example, they go through a CME review process, a medical review process, like you would put through a video or a journal. When we do content for like the life science industry, for pharma companies, the game content has to go through a medical, legal, regulatory review process to make sure that we aren't making any claims or featuring anything in the game that might be interpreted as being representing, let's say, an off-label use or making a claim that hasn't been validated by the FDA. And so you look at that and be like, how does a game developer operate in that kind of environment? And after years of making games for Hollywood movies, it's very, very similar. When you're making games for Star Wars, you can't just be like, oh, and now I'm going to have that shoot green lasers. Like, no, that gun shoots red lasers. It's in the archive on the ranch, go check. And, if a certain actor in the Hunger Games thinks he looks 20 years younger than he does, and it's 2 weeks before the game ships, and he thinks his likeness looks too old, you have to change it, because that is the only way the game gets creatively approved and launched. So throughout the games industry, we have similar processes that we employ, and the idea is to make sure that you're using those production processes even when you're making games for doctors. Like, there's always usually some reference that you can use, whether it's game design, engineering, or from a production standpoint, of other areas in the games industry where we face similar problems that can be adapted to games for doctors. Red sweater in the back. How are we using AI? So we are using AI a lot. And I actually give talks now in healthcare about how video games basically serve as a model for embracing generative AI. The example that I often use, because there's a lot of apprehension about, here, let me find some Gen AI stuff. Let's see. Here we go. So I'm going to skip through this pretty quick, but basically, games are an exemplar for an industry that's embracing generative AI. Everyone else is looking at generative AI. They're like, oh no, my job. Oh no, what is this going to mean for, how can we trust anything anymore? Everyone's freaking out. And, we're doing our share of freaking out, don't get me wrong. But in video games, I think we have a much healthier way that we think about it. And that is, I always say is, you can't make this, right, with the tools that you use to make video games decades ago. If you're in the video games industry, the expectation is always that whatever you were doing 5 years ago is now going to be automated, and you're going to be doing something completely different. And if you're doing the same thing you were doing 5 years ago, something's wrong with you. You're falling behind. The example I always give is Chicago. You're not going to create watchdogs. You're not going to, you can't make the city by hand down to each blade of grass, right? You need tools for that. And so in the video games industry, we've just been constantly evolving our toolbox every 5 years. How do we deliver an order of magnitude more content with an order of magnitude greater detail? And so we're constantly finding new ways to do that. We went, from better modeling tools to procedural content generation, where we're using math to generate, so an artist can just draw a street and then it fills in you've probably seen some of the demos. And the point that I make for healthcare is I'm saying, actually, the video games industry is using the content we've generated, using the last generation of tools in order to drive the next generation. So we're actually using the content generated by procedural systems to train our Gen AI. I use the examples from, I like to use the examples from, Unreal Engine of procedural content generation, and how, for example, we'll talk about, here, this is, the stuff I showed you, right, in healthcare are examples of procedural content generation in healthcare. But here's an example from Unreal of basically using simulated data to train AI systems to generate better looking characters. So this is next gen. You can actually download this demo, I think, in Unreal Engine 5.3. But basically, this is Gen AI generated musculature and body and animation simulation trained on procedural simulation. And so we're starting to, and so there are applications of doing this in healthcare, right? The example I give is, all right, well, we know when you're playing Gastro X, we're generating these realistic images. That's more pixelated than it should be. But we know when we're generating these images exactly where everything is in the scene. So just like in video games, how we're using procedural systems to train AI systems, healthcare can use the same models. And so some of the things we're starting to explore with our parent company, Brain Lab, is how to use basically game footage that's tagged with, yeah, here's the position of everything, here's where the light is, here's the anatomy, to train smarter AI systems. So I actually think this is just another area where video games and video game technology is paving the path for the rest of the world to go solve their problems. So in this case, like to go train smarter AI systems, the same way we're training our systems in video games. A question? Yes.
What's usually the process of porting games?
I mean, generally, the way we would do this years ago is different than the way it's done today. So generally today, most games are built using a third-party engine that generally supports both the PC and the console. So generally, like the move to, port from one platform to another is pretty much supported by the engine. Most of the work that you end up doing is, mapping input and whatnot. Definitely at Microsoft, we made great effort to make sure that porting between Windows and Xbox was easier by providing sets of, let's say, shared APIs, like DirectX, for example. But yeah, I think a lot of effort has been made by the industry to make that process as easy as possible. The idea should be that like a great artist, designer, game developer should be able to make a great game and be spending their time making the game awesome, not figuring out how to deal with the subtle differences between hardware and software platforms. If they do their jobs right. Dan, yep. Okay, so we're Level X, we're 130 people. We use both Unreal and Unity. Our studio looks like pretty much any other game studio. We have QA team, art team, design team, engineering team. Within those teams, there are disciplines. Art has technical art, UI art, 2D art, 3D art. It all looks just like any other game studio. The difference is we also have a medical team. So we have a team of biomedical engineers and MDs who are responsible for essentially, that thing that we talked about, like how do you quickly ramp up somebody on a very deep topic? That's their job, to figure out, all right, how do I stand over how do I direct the artist and give the artist the information they need to make that plaque psoriasis look realistic, right? What are the things they need to know about, actually this disease is above the pigment, below the pigment. That's why, on this skin tone it's gonna look like this, but on this skin tone it's gonna look like that. That's the sort of information that they would be collecting to help inform the artist or the engineer or the designer on how to make the game. Yeah.
How do you measure the degree of success and effectiveness?
How do you measure the degree of success and effectiveness? You're talking in healthcare. So in healthcare, here, let me put this. So in healthcare, we have a bunch of different ways that we do it. One is that those efficacy studies I did on my game I did for my dad was just the beginning. So at Level X, we're constantly working with academia to do efficacy studies in different, for all of our games. So they're constantly testing with different groups. Usually they'll test with medical students or residents. Often that's because they're easier, you can recruit them with pizza. Because we target practicing doctors, we'll often invest in doing specific studies with practicing physicians. So we just published a study with practicing dermatologists where the average person in the study had been practicing for like 15 years and sees 150 patients a week. So that way we can validate that our assumptions aren't just great for early learners, but also work for someone who is a continuing learner. So we test, obviously we see improved performance in game. We do tests where we see performance over time. We do tests where we test like clinical skills and in some cases like surgical performance, post-game, in the OR, in the clinic. And there's just sort of also lots of data that you can collect to identify and validate that the things that you're doing are really moving the needle.
Yeah, similar question. And just in the practice of it, so how have you guys?
So I think the answer is you don't necessarily need to make it as realistic as possible. I think that's really where the neuroscience comes in. One of the things that we talk about in both video games and in education is optimizing cognitive load. So you don't necessarily want to bombard the person with like all. I always show these examples. Here, let me find this deck real quick. 3D. I gave a talk recently at Games for Change, which was basically me just ranting about, stop it. Like, we see a lot of the default of, like, no, you notice I just gave this whole talk and I didn't say gamification or serious games once, not because these aren't very descriptive words, but because they've been stigmatized. So what everyone tries to do is they're like, oh, I'll go create the whole operating room or the whole clinic with all this stuff and all these buttons and da-da-da-da-da, and you spend 2 hours learning how to play the game and you never actually learn the thing you're supposed to learn. So the thing that we spend a lot of time focusing on is like, no, not as like, oh, can we recreate this and that, but like, what is the specific thing you need to learn here? And making sure that we take you right there and that you're doing that. So this is a big part of the design. It's really understanding like what are the things that make you like the questions we'll ask a doctor, right? So for example, you just ask a doctor like what's hard about your job. They'll tell you what's hard for a resident to learn, but not what's hard for them. We actually made this mistake early on. In GastroX, for example, we had built this whole system, which was super cool, where you could like inflate. So one of the ways you measure the difference between an expert and a novice in gastroenterology is the colon is basically a deflated balloon. And so, when you have the ability to like, you can basically inject CO2 to inflate it so you can see where you're going, but it's uncomfortable for the patient. So one of the ways you measure an expert versus a novice is an expert, a novice has to constantly inflate the colon to see where they're going, and the expert doesn't have to. So the expert is actually using less cable as they do it. You can measure that. We're like, oh, this is an awesome mechanic. We're going to create a whole thing where you can inflate the colon. We did all the physics for the pressure, It's super cool. And then we showed it to the gastroenterologist, and they were like, yeah, it's boring. Like, but you said this was hard. Like, well, yeah, it's hard for a resident. But once you get good at inflating the colon, it's just natural. We know our way around. The hard part is dealing with the bleeds and just take me to the action. This is an example of like you ask somebody what's hard, they will give you an answer. They're not being malicious, but you can't, it's just like if you ask somebody like, oh, what game would you like me to make for you? Oh, I want to have a game where I, have a machine gun that shoots rockets and lasers, and it's like that would actually be terrible. But so how do you ask the right questions? So the kinds of questions that we ask are like, okay, tell me about what's difficult about this procedure. Walk me through the procedure step by step. How do you know you've done it right? How do you know you've done it wrong? What are the things you hear? What are the things you see? What are the things, like what are the little indicators? Because that's the stuff you want to recreate. It's not necessarily the fluids or the air or whatever it is. It might be something you don't even think about. 2 anesthesiologists, if you know the pulse ox machine, the beep, 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 most people don't realize the pitch of the tone of the beep, beep, beep is the oxygen saturation. You and I don't even notice that. 2 anesthesiologists standing down the hallway from an operating room having a conversation, they're just talking. All of a sudden that pitch dips slightly. You wouldn't even know it. Immediately they both stop talking, they turn their heads, right? Because doctors are tuned to that kind of thing. Understanding what those cues are is super important to making a video game that can then trigger those cues. Because what are you trying to do? You're trying to trigger... how am I doing for time? I got like a minute. You're trying to trigger dopamine. You're trying to trigger stress hormone because that's what makes people remember. They don't remember from reading. They remember you make a mistake and then you go, oh, and you stress hormone and then you remember it. You do it right. Oh, dopamine. Great. What we're trying to do is trigger the same neurochemicals and therefore create the neuroplasticity and change behavior. But this is where you get into deep, deep game design. This is not the gamification crap, right? This is not like, oh, here, do this thing and I'll give you a badge. Like, this is, all right, how do we deeply understand what is challenging about this, what is rewarding about this, and then make sure we capture that and only what we need to capture to make a game that's easy to play, sort of easy to learn, difficult to master. Okay. So feel free, I think this is my LinkedIn, so feel free to follow me on LinkedIn. I always post fun stuff about video games, healthcare, AI, sort of continued ranting. Thanks, Ann.